Hello, everyone. Today, I'm going to introduce analysis of variance, simply called ANOVA. Now, we learned the t-test. There, we are able to compare two groups of samples. Now, that was the limitation for t-test. Now, ANOVA allows us to compare more than two groups of samples. Okay, let me just switch it to the Word file. Now, when it comes to ANOVA, we also needed to think about our interested variables level of measurement. Now, for grouping variable, it should be nominal or ordinal. They are called categorical level of measurement. Now, in t-test, we also use the grouping variable. As you may remember, we compared boys and girls verbal skill, and that was one example I showed out of a PowerPoint slide. So in that case, gender was grouping variable. So that grouping variable should be nominal or ordinal. Now, other variable is also needed, and that variable will be used when we actually compare two samples and three samples and four samples and so on. So the typical format of hypothesis for ANOVA is like t-test. There is a relationship between variable A, which is a grouping variable, and variable B, which is comparison variable. Now, let me just switch to our PowerPoint slide. Okay, so as you see over here, we can compare more than two groups of sample 1 through sample 3. You can add more samples, sample 4 and sample 5, it doesn't matter. And in this example, coincidentally, they have the same sample size, but you don't have to have the same sample size, okay? And those samples mean value. M is mean value, whatever that is. We don't need to know the details of this example. And whatever the mean value is, we're gonna compare the mean values among those three samples. That's typical format of ANOVA test. Now let me directly go to, okay, before we're going to another example, now, the question we may have is, what kind of statistic will be used for ANOVA? We are going to use F statistic. Let me check. Okay, F statistic. Let me make it larger. Okay, F statistic is, as you see over here, variance between sample means over variance expected by chance. So, to make this complicated idea simple, I should say F statistic is comparing variance between samples with variance within sample. The question is, what's that mean? That will be explained by using this example, okay? So, in this example, researcher is examining the effect of temperature, 50 degrees, 70 degrees, and 90 degrees. The effect of a temperature on their learning performance, okay? So, in this case, they chose 1, 2, 3, 4, 5 students in each sample, okay? But again, you don't have to equal number of samples for different sample, okay? They can be different. But anyway, 5 students were chosen for each sample. Obviously, they put in the different room with a different temperature setting, 50, 70, and 90 degrees. And researchers want to know whether or not there is a significant effect of temperature on their learning performance. So they gave an exam or test and graded it and found their mean value of score. Now, again, let me just pause a little. Again, the researchers' interest is the effect of temperature, okay? Now, however, in each sample, the students cannot be same because they may have a different background, family background. They may have a different number of studying hours. They may be different in their gender. They may be different in terms of household income. So they cannot be same. So this different score may be coming from their different background, but that is not the interest of the researcher. Researcher's interest is what? The effect of temperature on the learning performance. So that's why three sample group will be is divided into this way, having different room temperature. Okay, so although their different score may be coming from different background, that is called variation within sample. Variation within sample. So going back to this F statistic, the denominator is about variation within variation within sample. Okay, family background, whatever gender, all sorts of different factors are related to the difference in individual score, and that will be compared with actual score difference between sample. So this means the score difference is coming from only the different room temperature in different samples. So these two kinds of variance will be compared, and that is called the mean sum of standard deviation between sample versus mean standard deviation within sample. Okay, so that ratio is called F statistic. Okay, so simply put, F statistic will be used if F value is too small. That means the possible difference in terms of mean score in this example is not due to the different room temperature, rather it's due to different variation within sample like this. So if variation within sample is large enough, F value will be going down, will be smaller and smaller, and that means there is no significant relationship between room temperature and their learning performance. Okay, let me. So in the next video, which will be separate, I will show you how to develop analysis of variance ANOVA hypothesis, and I will show you how to run it. Okay, so let me stop you now.